This is a video from the Exam 4 review in my Calculus 2 class. Let's take a look at problem 11. Show f of x, which is equal to the summation from n equals 0 to infinity of x to the n over n factorial is a solution to f prime of x equals f of x. So let's start with f of x equals the summation from n equals 0 to infinity of x to the n over n factorial. F prime of x is the summation from n equal 1 to infinity of nx to the n minus 1 divided by n factorial. Now remember, n factorial is equal to n times n minus 1 times n minus 2 all the way down to 3 times 2 times 1. But we can write this as n times n minus 1 factorial. So what does that mean? F prime of x is the summation from n equal 1 to infinity of nx to the n minus 1 divided by n times n minus 1 factorial. So notice how the n's cancel and we get the summation from n equal 1 to infinity of x to the n minus 1 divided by n minus 1 factorial. But I want that lower limit to start at 0 instead of 1. So I'm going to rewrite this as the summation from n equals 0 to infinity of x to the n plus 1 minus 1 divided by n plus 1 minus 1 factorial. So what's happening is when you move the lower limit down 1, I need to replace the n with n plus 1 to counterbalance the move, essentially. But this says f prime of x is the summation from n equals 0 to infinity of x to the n over n factorial, but that's the same thing as f of x. And so that shows f of x, which is equal to the summation from n equals 0 to infinity of x to the n over n factorial, is a solution to the differential equation f prime of x equals f of x. And that's number 11. Number 12, show f of x, which is the summation from n equals 0 to infinity of negative 1 to the n x to the 2n is a solution of the differential equation f double prime of x plus f of x equals 0. So we're going to start with f of x, which is the summation from n equals 0 to infinity of negative 1 to the n x to the 2n divided by 2n factorial. When I take the derivative, I get f prime of x is the summation from n equal 1 to infinity of negative 1 to the n times 2n x to the 2n minus 1 divided by 2n factorial. Take the second derivative. If I take the second derivative, that's the summation from n equal 1 to infinity of negative 1 to the n times 2n times 2n minus 1 x to the 2n minus 2 divided by 2n factorial. Okay, notice the lower limit didn't change from the first to the second derivative. And I would convince myself by writing out a few terms to make sure that makes sense. But interestingly, if I took the third derivative, okay, the lower limit would change. Now, from here, f double prime of x is the summation from n equal 1 to infinity of negative 1 to the n times 2n times 2n minus 1 x to the 2n minus 2 divided by 2n times 2n minus 1 times 2n minus 2 factorial. Now, the 2n's cancel, the 2n minus 1's cancel. And if you notice, to go from the first line to the second line, right, what I'm doing is I want the lower limit to start at 0. But if I want the lower limit to start at 0, I need to replace the n with n plus 1. And so this is the summation from n equals 0 to infinity of negative 1 to the n plus 1 x to the 2 times n plus 1 minus 2 divided by 2 times n plus 1 minus 2 factorial. And I could write this as the summation from n equals 0 to infinity of negative 1 times negative 1 to the n times x to the 2n divided by 2n factorial. And then from here, f double prime of x plus f of x is the summation from n equals 0 to infinity of negative 1 times negative 1 to the n x to the 2n divided by 2n factorial plus the summation from n equals 0 to infinity of negative 1 to the n x to the 2n divided by 2n factorial. But this is the summation from n equals 0 to infinity of the quantity negative 1 times negative 1 to the n times x to the 2n divided by 2n factorial plus the summation from let's start here. It's the summation from n equals 0 to infinity of negative 1 times negative 1 to the n x to the 2n over 2n factorial plus negative 1 to the n x to the 2n over 2n factorial. Now, I claim that's 0, but let's make sure that makes sense. Because notice how each term has a negative 1 to the n x to the 2n over 2n factorial. Okay? And I can factor that out. And when I factor that out, I get negative 1 plus 1 inside the parentheses. But negative 1 plus 1 is 0. And so that's the summation from n equals 0 to infinity of 0 times negative 1 to the n x to the 2n over 2n factorial. And, well, that will be 0. And so that will prove it. And so that shows f of x, which is the summation from n equals 0 to infinity of negative 1 to the n x to the 2n over 2n factorial is a solution of the differential equation f double prime of x plus f of x equals 0. 13a. Suppose f of x equals cosine x and a equals pi over 2. And we want the Taylor series for f centered at pi over 2. Start with f of x equals cosine x. Notice that f of pi over 2 is 0. Take the derivative. F prime of x is negative sine x. F prime of pi over 2 is negative 1. Take the second derivative. F double prime of x is negative cosine x. And then f double prime of pi over 2 is 0. And then the third derivative of f at x is sine x. The third derivative of f at pi over 2 is 1. The fourth derivative of f at x is cosine x. The fourth derivative at pi over 2, right? So I'm taking the fourth derivative of f and evaluating it at pi over 2. And notice how that's 0. So notice the even derivatives evaluated at pi over 2 ended up being 0. The odd derivatives at pi over 2 ended up oscillating between negative 1 and 1. Okay? And so how do I make use of that? Well, it turns out that cosine x is the summation from n equals 0 to infinity of negative 1 to the n plus 1. That'll account for the oscillating between negative 1 and 1. So I take negative 1 to the n plus 1, I'm going to divide it by 2n plus 1 factorial, and then multiply by x minus pi over 2 to the 2n plus 1. And I'll let you guys figure out the radius of convergence. And that's why I put r equals, and then what would that be? 13b. Suppose f of x equals sine 2x and a equals pi. And so I want the Taylor series for f centered at pi. Now, if f of x equals sine 2x, if I take f and evaluate it at pi, I get 0. F prime of x is equal to 2 cosine 2x. F prime of pi is 2. F double prime of x is negative 2 squared sine 2x. F double prime of pi is 0. And so it looks like on the even derivatives, when I take an even derivative and evaluate it at pi, I end up getting 0, is what it's looking like. So when I take f triple prime of x, I get negative 2 cubed cosine 2x. F triple prime of pi is negative 2 cubed. The fourth derivative of f evaluated at x is 2 to the fourth sine 2x. The fourth derivative of f at pi is 0. The fifth derivative of f at x is 2 to the fifth cosine 2x. The fifth derivative of f at pi is 2 to the fifth. And then from here, sine 2x is the summation from n equals 0 to infinity. You get of negative 1 to the n times 2 to the 2n plus 1 divided by 2n plus 1 factorial times x minus pi to the 2n plus 1. And I will stop here. This will conclude the video for the exam 4 review, and we looked at problems 11, 12, and 13. Thank you.